Hello and welcome everyone. This is Manish from Scalable India, and today we are going to start a new topic, which is reverse engineering. And as a design engineer, it is a very important topic for you to understand about reverse engineering. That what is the need and what are the advantages, benefits, applications of the reverse engineering. Okay, so step by step we will be understanding each point, and we will be clearing all these things with the help of examples, and how it is being applied in the 3D CAD CAM softwares, how you will take the data. All these things we are going to discuss in this. Okay, so let's start our new topic, which is reverse engineering. Okay, so first of all, this thing, how it can be used for rapid prototyping. Okay, so all these things we will discuss in this. One of the common way to understand reverse engineering is first we have to understand that what does engineering a product means. Okay, so first, before understanding reverse engineering, first we will understand that what engineering a product means. Engineering a product means. Okay, so this concept is defined that where the concept has been created. Okay, so before when the concept or idea has been created to create a product, so we have to do on that idea or on that concept, we have to make the engineering concepts. Okay, so we have to engineering a product or develop a or we can say develop a prototype, or we can say develop a CAD design. So first, in engineering product, first we have to create a concept or idea. Idea has been created, then engineering a product. In that, design is involved, prototyping. So all these things comes under engineering a product. Okay, so all these ideas should be verified, then prototyping or visual prototyping or a physical prototypes are being developed, and then only the final product is being created. Okay, so this, as we know, that engineering a product is a iterative process. Okay, so because this is a iterative process, this is a iterative process and required specific knowledge on that products. Okay, so engineers are working on new ideas on a regular basis, and to develop a product with the help of 3D CAD CAM design, with the help of visual prototyping, with the help of documentations, processes involved in that. So all with the help of all these, you are engineering a product. Now we will understand the concept of reverse engineering. Now, reverse engineering concept is just opposite to it. We have a physical product. Let's say we have a physical product. Now we have to reverse engineer it. Reverse engineering done, and then why we do, to understand the concept, to understand to understand the functionality, uh, design, material. So this is why we have to do a reverse engineering. Okay, so we have a physical product, then we have to reverse engineering, we have different kinds of method that how we can do the reverse engineering. We will later on understand that what are those methods to reverse engineer a product, and then we will find out the concept behind that product. Okay, so the functionality it is working, the design or material which is having into the product. So all these things we will be doing, and again with the help of that concept we will able to make the 3D CAD model. Okay, after making 3D CAD model we will move on to the prototyping of the reverse engineering product. So from product we are creating a product. Okay, so this is reverse engineering is a very important aspect as a design engineer, and one by one we are going to understand that how it is important to go through all these things. So what are the fields? First we will understand that what are the fields where this reverse engineering is required, where reverse engineering is required. Okay, so there is a in softwares reverse engineering is very famous. Okay, so in this algorithm or the programs which have been created, the engineers also do the reverse engineering to understand the concept of those algorithms or programs. So in the software development this reverse engineering is very common, and it is very common field to do the reverse engineering to understand the working, to understand the functionality of the program. Okay, other is a or we can say mechanical assemblies. It is very common. I will tell you this thing that in mechanical assemblies, like if you are in a war-like situation and the other party is having a higher artilleries than yours, so if you got some artillery from the other party, so on that artillery you have to develop that concept. If you have to understand that what concepts they are using in their artillery, so you have to reverse engineering that product or that artillery, that is specific product. Okay, so this is where the mechanical assemblies are required to be reverse engineering, or the competitor is in the market who is gaining much more attention than your product. So again, if you want to know the functionality of his product, or if he is making some extensively growth in the market, then you have to reverse engineering the product and understand the functionality of his product. Okay, so understanding the functionality, understanding the design. So with the help of these reverse engineering process, this all be possible. Okay, there are other also, like in electronics there is a printed circuit boards. So it is also very common practice which has been learned to reverse engineering printed circuit boards. Okay, for PCB design, reverse engineering design of PCB. So it is but one of the field, like chemical engineering. Chemical engineering, chemicals are also reverse engineered. Okay, to know the chemicals involved, or to know the let's say that which type of chemicals are involved into that chemical. So like there are n number of chemicals. So this is one of the field where the chemical reverse engineering is being done. In all, obviously I have told you about the CAD models. So sometimes from physical part you develop you reverse engineering it and make a 3D CAD model. So this is also a field where you are using this reverse engineering. Okay, so the need for building CAD models for from physical part, why it is required, why it is a need. So we will understand that how what is the need to do reverse engineering. Need to do reverse engineering. as we all know that 3D CAM/CAD models are very common in the automobile industry, but still they are using to make outer design of the car or outer design of the product in the automobile. They are trying to make into clay models. Okay, in automobile industry, though 99% of the work is being done with the help of CAD softwares, but still they are using clay models, or you can say wood models that has been easily can change, foam models. So these type of practices are also into the industry, like clay models, wood models, or foam models before making a prototype, before making a CAD model. So this is where the understanding is come into action, that when you are fully finalized with the clay model. Okay, so after that, that clay model, or let's take an example, there is a car. Okay, you have created with the help of clay model. Now this clay model is to be now this clay model is we have to create a 3D CAD model. So we have to we have to go into the reverse engineering process, okay, to make the exact 3D CAD model, and then only we can make our final model, final prototype. So this is one of the places where it is a need of reverse engineering is required, and we will understand later on that what are the I will say what are the exact methods to use this reverse engineering. Okay, so second need we will understand is if some, let's take an example, if you are using a machine from 20 years. Okay, the manufacturer who is manufacturing that machine has stopped its manufacturing unit. Okay, let's say one of the part of that machine is being wear or tear out. Okay, let's take an example, it's a plastic part. Okay, so now the part is not available into the market because the company has shut down its unit to manufacture that machine. Okay, so its spare parts are not easily available. Now if you want that part, then how you will go into that, how you will move in or fix that problem into your machine. So here also the reverse engineering comes into action, where the where you have the wear and tear part, wear and tear out part, and from this part you have to create you have to reverse engineering it and create 3D model of it into CAD software. Okay, so with that 3D model, if there is a one or two parts are required and it is of common plastic part or some metal part, then you can also use the additive manufacturing process to create that prototype. Okay, so create that part, you can use n numbers of additive manufacturing process, numbers of additive manufacturing processes to create that part, to create physical part. So this is also one of the need where the reverse engineering is very important. Okay, so this reverse engineering, when collaborate with the advanced technologies like 3D printing, additive manufacturing, it is very easily to develop a new products. Okay, so it is very common to develop a new product with the help of such technologies which are easily available into the market. Okay, now there are n number of printers are available into the market. With the help of those printer, you can develop a prototype, or you can check the dimensions of the prototype which you are going to make, or you are going to create tools for that part. Okay, so this is one of the easiest example I can give. Now I will move on to the third need, which is adequate or no documents having. Okay, sometimes some company is making an existing design from so many years, but the design or the documentation of that part is that they're not having exact 3D CAD model or the manufactured documents. Okay, so in that situation also we need to go into the reverse engineering process. Okay, so in this when the data is not available, or we can say no documentation of original design. Original design. So in this case also, you have a product, you have a physical product, but you are not having the 3D CAD model. So in this case also you have to reverse engineering it and make 3D CAD model out of it. Okay, with the help of this 3D CAD model you can make a prototype. Okay, and with the help of this 3D CAD model you can make tools out of it. Tools like mold, dies. So all these things you can make with the help of these 3D CAD model, with the help of reverse engineering. Okay, so this is where one of the applications where you can use this reverse engineering process. And there are n number of processes are also there. Okay, so to copy or analyze, so other we will understand. If you want to copy or analyze or understand the other's product, or we can say understand the other's product. Okay, so how you will understand or copy or analyze the understand the other's product functionality? So with the help of reverse engineering process, it is easily available to copy some product which is available into the market and to make the prototype out of it. Hence it is an illegal process, but sometimes company do, which the companies in a very common practice. They do these type of copying or analyze the product or make some little changes in that product or design, and they check the functionality, they check the understanding that how these products are been working, what are their concepts behind it. So all these things will be helpful for you to understand or to analyze the other's product. Okay, so this is one of the common fields. Now we will move on to the analyzing the changes in an old product. Okay, sometimes you have to analyze the changes in a old part. Let's say one part is manufacturing from so many years. Okay, let's say 5 years. Now you have to check this part. You have to analyze this part is in on the right side or not. Okay, so from this part you have 3D CAD model, but to you have 3D CAD model of this part, but still if you have to check or analyze this part, now you have to make a reverse engineering out of it, and you have to create one prototype from this part. Okay, by reverse engineering. So part 1 created with the help of reverse engineering, we create cloud data or point cloud data. So for any reverse engineering process, first we need to understand one thing about point cloud data. Okay, so for any reverse engineering, first we have to collect all the data. Data can be in the form of dimensions, data can be in the form of points, data can be in the form of n numbers of their places are involved in this. So all these point cloud data are being converted, okay, collected, and with the help of these point cloud data, we definitely making the product feasible. Okay, or make the reverse engineering easily available. Again, there is one more thing, to inspection. Okay, so sometime in inspection of a manufactured part of a manufactured part. So how you will let's say you have 3D CAD model and you have manufactured one part. Okay, now if you have to inspect you have to inspect this part, is it correct or not? Then with the help of this 3D part, you will create, with the help of reverse engineering, point with the help of point cloud data, you will create again the next 3D CAD model. Okay, so after this you will be checking while both the data 1 and data 2, which is created from the part only. Okay, with the help of reverse engineering, first this data make the part, and with that part we make again data. So both the data 1 and data 2, we will check that what can be the possibility they are actual the same or not. Okay, so you can check the deviation in the tolerances with all these data. So here also in the quality process, this inspection is being done with the help of two data. You have to merge both the data and check the deviation in the tolerances. So in this process also, in the quality, this reverse engineering is being done. Okay, so now we will understand what are the different steps which are involved in building, or let's say, a CAD model. Okay, so what are the steps involved? Steps involved in making 3D CAD data from product, in making 3D CAD data from physical part. So this thing we need to understand step by step. I will tell you that what's the process. There is steps involved in building a CAD model from physical parts. Okay, so there are n numbers of steps are involved. First of all, we will understand this like we have to digitize or collect data. Digitizing or collecting data from physical product. Okay, so first you have to collect all the data with the help of digitizing instruments. So if there is a simple, let's say there is a simple component, so with the help of measuring tools, like with the help of measuring tools like vernier or micrometer or radius gauges. So you can also collect data if the part is very simple. Okay, so all the dimensions you can collect and make with the help of this dimensions or this data, you can create a 3D CAD model. But it is a simple case. Okay, let's say you have some free form geometry. Okay, so in this case you can make or collect data directly from the model, and you can make into the 3D CAD model with the help of 3D CAD software. It can be any software. With the help of that software you can create a 3D model. But let's say there is a free form geometry. Okay, free form geometry where you cannot take dimensions directly. Okay, where it is not possible to take dimensions directly. Okay, so in this case, in this free form geometry, you have to collect all the point cloud data. So in this free form geometry can be of any type. Like if I'm in right now I have having one product which is like this mouse. Okay, you can see this mouse, and it is having a curved surfaces all around. Okay, it is having curved surfaces in the field of this also, like these. So if I have to cover and I have to make this model into a 3D CAD model, so first of all I have to collect all these points around it. Okay, and with the help of these point cloud data, I am going to let's say this is the profile like this. So I have to collect all these data to make this into the 3D CAD model. Okay, so these are points which we are going to collect. So how this is possible? Then after this, after I have collected the point cloud data, then I will send this data into the 3D CAD software, and then I will be in the next step when the collection of the data is done. Collection of data, then I will manipulate the data. Okay, manipulate the collected data to obtain a 3D CAD model. To obtain a 3D CAD model. So I will going to manipulate this data and to obtain a 3D CAD model. Okay, so with the help of this point cloud data, I will be ending up making 3D CAD model. Hence, it is requiring a lot of experience to do such things as a design engineer. Okay, so after that, the next step is using the CAD model to obtain a physical part. After generating 3D CAD model, to this 3D CAD model will help us to create or to obtain physical part, physical prototype. Okay, so this is what are the steps involved in this reverse engineering process. Now we will more deep dive into this reverse engineering, and we will understand again that what are the digitization or collecting data from physical parts. Okay, what are the steps involved in, what are the methods involved in collecting the point cloud data. So moreover, now we will understand steps, or we can say methods are involved for the digitizing or collecting digitizing or collecting data from physical part. Okay, so collecting data, let's say collecting point cloud data from physical part is one of the method. Okay, so there are two methods where how you can collect this point cloud data. So first, there are two methods to collect point cloud data. So first of all, there is a method which is called contact method. Then there is a method which is called a non-contact method. Okay, so in contact method, directly its names itself defines that in contact method it is contacting with the surface of the physical product. Okay, in non-contact method it is already name defines that it is the thing which is going to generate this point cloud data is not going to contact with the physical product. Okay, so in contact method the first thing which comes under is CMM. So with the help of coordinate measuring machine, or we can say this probe, with the help of probe we collect point cloud data. Okay. Or in non-contact method, you will see like take an example of 3D scanners. Oh, okay. So 3D scanners are very common practice which are used to collect large number of data or points to generate 3D CAD model. Okay, so this is a non-contact method where 3D mobile scanners or 3D large scanners are used to collect n number of data, n number of points to generate 3D CAD model. Okay, in contact method, there is a machine called CMM, coordinate measuring machine. So with the help of probe, the coordinates around that geometry or the complex part, we take n number of points, and with the help of those points, we try to create exact same model. Of the 3D CAD model while reverse engineering it. Okay, so these are the two common practices, and both the practices are very common into the industry. As a trainer, I have seen a lot of these things into the industry. Okay, so both practices are equally popular. Both the practices are equally popular into the industry. Okay, so now we have understand this thing, that what are the methods involved in this. Now, moreover, we will understand that how these collecting of data using CMM. Okay, so scan the part using a touch probe to get the point cloud data. Obviously, we know we have to touch it. We have to touch the probe with the product to collect the point cloud data. There are curves. Okay, so there are in CMM, there are in the part can be of curve surfaces. Then after collecting this, you have to create curve surfaces with the point cloud data. You have to give fittings with or merge the surfaces. Okay, so after collecting all the data, you have to do these things. Okay, so after this scanning of the part through CMM, these are you have to give some fillets or round to improvise your data, etc. Okay, okay, so again you will have to interrogate the design or the surface quality which you have made into the 3D CAD design with help of point cloud data. So these things are involved where you have to interrogate the surface quality, you have to check the merge between two surfaces, you have to check each and every point after collecting these data. Okay, so these are the practices which has been done. You have to do a certain manipulations after obviously we know we have to do certain manipulation with the data, certain manipulation I've already told you with point cloud data, or we can say point PCD. With point cloud data, like you have to give the blends, you have to give fillets, already told you rounds, and n number of commands you have to use to make the quality surface. Okay, so the data you have to manipulate to create the exact 3D model. Okay, so you have to interrogate the slope you have to again interrogate the slope continuities, or we can say curve continuities. So curvatures are of the surface. You have to check these things because whether they met or not, these type of practices requires a lot of experience. Okay, so a lot of experience is required and a lot of practice, experience and practice is required. Practice is required to make such type of interrogations, loop continuities, curve continuities. You have to blend the part, you have to give surfacings, you have to give surface trims. So all these commands you have to use again and again to get the correct 3D model. Again, the next thing I will say you is that in reverse engineering, there are again, let's take an first I will tell you with the help of example. Let's take an example. Okay, example of axisymmetric model or profile. Let's take an example with the CMM. Okay, so so this is a Z direction, this is a Y direction. Let's say that one of the model is being created like this. Okay, so these all the points you have taken point cloud data, and with the help of this point cloud data you are ending up making some you taking this into the 3D CAD software, where you will create a 3D CAD model with the help of this data. Okay, so like take an example. If you will be let's say you, this is a center line and you have to revolve this geometry. You have to revolve this geometry around this center line. Okay, so create a design intent in your mind that what will be the if you will revolve this geometry into center line, through a center line, what will be the exact part it will be created. Okay, so a bowl like structure will be created. Okay, so the like this type of structure in the 3D CAD model, bowl like structure is being created. Okay, so with the this bowl like structure, now you get the 3D CAD model, the exact. Okay, so if there is some requirement of the manipulation of this data, then you have to manipulate that data, and then you can create this part with the help of additive manufacturing. You can 3D print this part to check the correct dimension. Okay, so now we understand that why this data, why this point cloud data is so helpful, and why we take this point cloud data in reverse engineering processes. Okay, so sometimes the problem also come in this, that surfaces are not stitched, surfaces are not connected with each other, surfaces are not connected or joined or merge, connected or merge with each other. So there are n number of processes, like you have to use stitching. Stitching is one of the common practices done by the designers or design engineers to merge the two surfaces. Okay, so steps involved in collecting the point cloud data by non-contact method. Till now we have understand to collect the data from a contact method. Now on we will understand that we are steps involved in collecting data from non-contact method. Okay, so there are n number of 3D scanners are available. 3D scanning will be can be done by the white light, can be done by the lasers. Okay, so there is a intelligent scanning is also available into the market. With the help of mobile scanners, you can do the intelligent scanning from each and every side of the part. Okay, so reconstructing algorithms are used in this, that there is a not a specific point or coordinate in that. You are creating that part or with the help of 3D scanner in the free surface, okay, in a free area. So in a these reconstructive algorithms are used again and again in this. Again, this is a 3D scanner is a faster way. 3D scanners is a to create faster way to create 3D model 3D model into CAD software. Okay, so this is a faster way as we know this, and there are let's say CMM has some limitations itself. CMM having some limitations in this. Whenever you have to, let's say, whenever you have to some discontinuities, I will tell you the CMM limitations also. CMM or coordinate measuring machine have some limitations, like sometimes if you are having some discontinuities, probably pro in this situation probably probe cannot reach cannot reach reach those discontinuities. Okay, so sometimes the probe have its limitation, that sometimes in discontinuities probe cannot reach at that point, but technology is a little bit higher, so nowadays the expensive machines are available, but still it is having some disadvantage over the 3D scanner. Okay, so you may have some data which can lost, so sometimes the data can lost. Okay. So this type of problems are being done in 3D scanning. A large amount of data is being collected. So with the help of that data, it is easily make to a 3D CAD model. Okay. So how we will use a captured data. What we have captured data to create a model. Okay. So what are the applications? So with the help of this captured data, you can directly create a NC program. Okay, NC program can be created. NC program generation can be done directly and give it for the making a prototype. And sometimes if this is already you have prototype in additive manufacturing, prototyping stage has been already completed, then you can create a mold out of that data, and you can generate n number of parts. Okay, again the next thing you can do, you can directly go into the rapid prototyping stage also. Rapid prototyping you can do, I have already told you this, that you can directly rapid prototype with the help of 3D printing. These techniques are very common. Okay, so inspection of the part, if you have to inspection of the part is available, so also you can inspect the part with the help of these captured data. Okay, so now on, I think we have understand this concept of reverse engineering. So first thing, we will understand this inspection of the part in little bit of detailed manner, because these are the common practices it been done into the manufacturing industry. Okay, detailed manner we will understand this. So how you will inspect the part? So first you have to understand there are two methods to inspect the part. First is we will say part localization for inspection. Okay, locating manufactured part with respect to the design part. Okay, so in this method, localizing a part, we will be locating the manufactured part with respect to the design part. This is a manufactured part, And with respect to the design part, with the help of design part, we will be checking its tolerances, its deviations, all these things we can check. Okay, so this is how with the deviations, intolerances can be checked for inspection. Okay, so with the help of manufacturing part, with respect to the design part, so we can check by combining both of them, we can check the deviation and tolerances. Okay, so this is one of the thing. Again, second use of datum. Okay, so localizing by optimizing. First, you have to provide one specific datum. Let's say a specific datum or surface. Now on that surface, you will be checking both of them. With the help in respect to the datum, you will check both the parts, what are the discontinuities, what are the differences between that. So this is also the common practices which is being used into the industry to inspect the part with the help of reverse engineering process. So error measurements can be checked with this, that what can be the possible error in the deviation, if the deviation in the tolerances has been done. So it matches the design geometry within the certain tolerance or not. So can be, these type of things can be checked in this, that sometimes there is a problem in certain tolerances system. Okay, certain tolerances cannot matches the design geometry. So all these things can be removed from this type of inspection. What are the industries reverse engineering are popular? In each and every industry, I will say, like automobile, healthcare, consumer products, aviation, these practices are very common. Okay, so nowadays there are faster method, like mobile scanners available, mobile scanners in the form of small scanners, which are portable scanners are available. So you can create easily prototype. Okay, you can easily generate a 3D CAD model with the help of these portable scanners. Okay, so this is very upper hand. And in this reverse engineering of product development time, product development time is also considerably reduced in many cases. Okay, so the benefit is product development time is also been reduced, is also been reduced extensively. Okay, so considerably the time is also been reduced to create a prototype. It's a very important tool, very important process. It's a very important process of reverse engineering. Okay, even more beneficial when it is combined with the additive manufacturing techniques, like selective laser sintering or stereography for the 3D printing processes. So fusion melting process, all these things are very familiar, and it increases the time, development time. It reduces the development time of the product. Okay. So this is all for the today's lesson of on reverse engineering. I hope you get some basic understanding of the reverse engineering processes. So now on, I will be ending this lesson. Thank you very much.